Hi, this question is about the rotational motion from the practice exam 2024, in which we will try to find out an angular acceleration in this board, which is supported right now with the help of the two strings, string B and string A. So, if an event happens that at the time t is equal to 0, the one of the strings, string B, if it breaks from that point, so what will be the angular acceleration immediately after? Why we say immediately after? Because if little bit after later time, what will happen? This string, since it is not rigid, so this system will be like this. So in which you won't have the constant angular acceleration, it will be changing. So we have to find out the angular acceleration about this pivot point. So we assume that this is our axis about which the system will rotate immediately after. So it will rotate like this. Now, if we place a mass of 2m right at that point, and whereas the board have a mass m, so due to these two forces, what two forces? Because this board have a uniform mass, so its weight should be exerted right from that point. So it should be mg. Whereas this its mass should be, its weight should be twice as time more than this, so it is 2 mg. So these are the two forces which are responsible for producing the torque, and that torque will produce an angular acceleration in the system. So we are taking this point pivot. So let's try finding out, do we know the distance from the pivot? So yeah, we know, since this should be L over 2, and its torque produced is clockwise, whereas this distance is x, which we will consider while calculating the torque. Now, so what is the total torque? So we should say that the net torque is equals to the sum of all moment of inertias times the angular acceleration. Okay. Now, and we only have the two torques which are both clockwise, so we can take their magnitudes. So the first of all, mg times L over 2 is the torque produced by the weight of the board, whereas plus 2 mg times x is the torque produced by, clockwise torque produced by, this mass that we have put at that point at a distance x from the pivot, and that should be equals to the sum of all moment of inertias or the rotational inertias. Now we know that we will consider it as a point object. Okay, so since it is placed at a point at a distance x, so I would say it's it's should be 2mx square is the moment of inertia of that one, plus, and this is a rod. Now look, this is a rod, a board is like a rod who's pivoted at this point. So that's why its rotational inertia will be 1 over 3 ml square. Otherwise, if the pivot will be passing from the center, then you know it is 1 over 12 ml square. Okay, so that's why we should consider 1 over 3 ml square times L over 2. Sorry, we should multiply it with alpha, right? Since we want to find the alpha, right? So, but before that, we should take mg common from here. So inside we have L over 2 plus 2x. And on this side, we can rearrange it like this. So you may take the m outside the bracket. Inside we have 1 over 3 L square plus 2x square. Now to get alpha, we should take this, or we should divide this quantity or this term on both sides. So then it will become, inside we have 1 over 3 L square plus 2x square, that is equals to the angular acceleration. So you can cancel out this mass with this mass. Okay, so finally you can see that our angular acceleration is equals to this option D, whatever reason here. So this will be the angular acceleration produced in this bar, but it will change because It is not a rigid string. That's why. So this is immediately after the string is cut.